Hello there guys, welcome to my channel. Okay, in this video I'm going to explain to you about chemistry paper 2 22 and it's February March 2021. The time duration is 45 minutes. Okay, let us go to the first question. Okay, number 1, which row about a change of state is correct? Okay, now that there is a change of state, is the energy change and there is a process. Okay, now we just make it simple here: solid, liquid and gas. So when it is going from a solid to liquid and liquid to gas, always remember the energy is being absorbed. Alright, so let me make it higher. Okay, so this one is a heat energy being absorbed, and gas to liquid and liquid to solid, this one the heat energy is being released. Okay, so these are the process. Okay, now solid to liquid, which is supposed to be evaporation, is melting, so strong. Gas to liquid supposed to be a condensation, but they wrote here evaporation, so strong. Solid to gas is a sublimation and heat taken in. Yes, they absorb heat, so this one is most possible answer. And liquid to solid supposed to be freezing, so it's opposite, so this is condensation, so the best answer here will be the C. Okay, now let us look at the next one. Okay, number 2. Okay, here gases are separated from liquid air by fractional distillation. The boiling point of 4 gases are shown. Which gas is both monoatomic and a liquid at the negative 200 degrees Celsius? Okay, monoatomic here, the most possible answer here will be in the group 18, which is the inert group. Okay, now let's say we have a nitrogen here. This is definitely is not the answer, because nitrogen is appeared as a atom here. Okay, so now so here we write the borderline, and I write here is a boiling point. Okay, so boiling point, it means it's a liquid to gas, so here's the liquid to the gas. Okay, now let us look at argon. Their boiling point is a negative 186. When it's a negative 186 degrees Celsius, so it means that the argon changes from liquid state to gas at this temperature. Okay, so it's a negative 200 is at this side, so it is in the liquid state. Okay, so now if you look at the other gases like a helium, it's a negative 269 degrees Celsius. It means it is changing from a liquid to gas at negative 269 degrees Celsius, which means the negative 200 here, it will be in a gas state. Okay, so this one cannot. And neon, let us look at neon. Neon, it has a, let me scroll down. Okay, neon, it has a boiling point at negative 246. So let me just write here negative 246. So which means now we are following the number line. So which means the negative 200 will be at here. Okay, is higher than the boiling point. So it means that the neon also having gas as a state of matter. So the only one answer that we have here is argon. So 2 is A. Okay, now let us look at number 3. Okay, number 3. two different food coloring X and Y are tested using a chromatography. 3 pure dye 1, 2, 3 are also tested. The chromatogram is shown here. Okay, this is solvent front and this is the baseline. So we have a dye 1, 2 and 3. Okay, so now let us scroll a bit lower. Okay, so now over here, which statement are correct? Okay, now number 1, X and Y both contains 2 or more dyes. Okay, now let us list down over here. So if you look at X contains, this is 3, they have 3. They do have 2. So X contains dye number 2 and 3. Okay, let us look at Y. Y, they have the same 3 and 2. So they have the same 2 and 3. Okay, now X and Y both contains 2 or more dyes. So 1 is correct. Okay, now let us look at number 2. Dye 2 and 3 are present in both X and Y. Yes, is correct. Okay, number 2 is correct. Okay, number 3. The RF of dye 1. Okay, here the RF of dye 1, which is 5. Okay, now let us look at the calculation here. So we have to calculate based on this. Oops, I make the line. Okay, we have to calculate based on this line, the green color, and also you have to follow the baseline to the solvent front. So which means, okay, is 5 over 8. That is the RF value for dye number 1. So let us calculate this. So 5 divided by 8, yes, I'm getting here 0.625. Yes, so number 3 is also correct. So now the best answer here will be everything. So it's 1, 2, 3. So C is your answer. Okay, now let us look at the number 4. Okay, which statement about the atoms of all the isotopes of carbon is correct? Okay guys, so please remember the isotopes of carbon. So they have 12, carbon 12, carbon 13 and carbon 14. And remember, for the isotope, all the proton number are the same. Okay, so if you do like a comparison, so let us look at their proton number, electron number, neutron number and nuclear number. So now, so let's say I put here proton, electron, neutron and nucleon. So here will be 6, 6, 6, 6, 6 and 6. The neutron you have to minus the nuclear number. This is nuclear number and this is a proton number. So is 6, this one will be 7 and here will be 8, and the nuclear number is the number on top here is 12, 13 and 14. Okay, so please remember this one guys. Okay, now they are all radioactive. No, definitely is not. It's not all the isotopes are radioactive. So only carbon 14 is radioactive. They involved in this archaeology. So this is not. So they have the same mass. Definitely not, because here is 12, 13 and 14. So it's not the same. They have the same number of neutron. Nope. Okay, they have the same number of electrons in the outer shell. Yes, because they do have the same electron number and their electron arrangement is 2.4. Okay, so at their outer shell they have 4 electrons. So your answer here for number 4 is D. Okay, so now let us move from number 5. Okay, number 5. Which diagram represents the structure of a silicon oxide? Okay, silicon oxide is this. Okay, so these are the molecular formula. Okay, now let us look at the every structure here. Now A, they have a tetrahedral structure where this is a diamond. Okay, this is a diamond. So everything here will be the carbon. Now, the carbon also forms graphite. And the graphite is very slippery due to this layer. Okay, so they have this layer. So layer should be here. So the layer, so here we have a layer 1 and layer 2, and they are weakly bonded by this. Okay, so they have this weak bonding. So this is more to graphite, and everything here, all the atoms here is carbon. Okay, now if you look at C, this is more to a lattice structure where it involves ion bonding. Okay, so they have a positive, negative, positive, negative, positive, negative. So this is a lattice structure. It's an ionic bonding. Silicon oxide is a covalent bonding. So if you look at silicon oxide, so they have silicon is from a group 14. So it will be like a 4 plus, and when we look at oxygen, is a 2 negative. So when they combine, they will form 2 silicon 2 and also oxygen 4. So for every silicon is bonded with the 4 oxygens. Now look at here this part. Okay, so the simple formula is given by silicon oxide. So the D is your answer. So I hope you can understand this. Okay, now let us look at the question number 6. Okay, number 6. Lithium and fluorine react to form lithium fluoride. So before we proceed, so I just write it down here. This is group 1 and this is a group 17. So they will form an ionic equation, ionic bonding, because this is a metal and this is a non-metal. So the group 1 will form a positive ion and the fluorine will form a negative ion, and they will have a strong electrostatic force to attract them and form the bonding. Okay, now let us look at one by one. So a student writes 3 statements about the reaction. Number 1, lithium atom lose an electron when they react. So they donate. This one will be a donating the electrons, and the fluorine will be receiving the electrons. Okay, so now let us look at number 2. Okay, each fluoride ion has one more electron than fluorine atom. Ion has one more electron than a fluorine atom. Yes. So if you look at this periodic table, fluorine has 19 and 9 here. So if you look at the arrangement, the electron arrangement, this is 19. Okay, electron arrangement of this fluorine is a 2 and 7. This is for the fluorine atom. So if you look at the fluorine ion here, once they accept one electron, it will become 2.8, which is more. So it means this 2 is correct. Okay, lithium fluoride is a mixture of elements. So this is not right because they are chemically bonded. Okay, so it's a compound. So 1 and 2 is correct. So your answer here will be A. Okay, now look at number 7. Okay, how many electrons are used to form covalent bonds in a molecule of methanol? So let us draw the structure of this methanol. So we have one carbon, we have a O hydroxide, so here will be hydrogen, and here is also hydrogen. So they are asking how many electrons are used to form the covalent bonds. Okay, so every bonds here, it involves a pair. Okay, one pair of electron, which means is 2 electrons here. So 2 times with, we have there about 5 bonds. So supposed to be they have a 10 electrons. Okay, if you still cannot get this the picture of this, let us draw Levy structure. Now carbon, they have a 4 valence electron. Now hydrogen, they have 1. So I'll draw the cross for the carbon and the dot for the hydrogen. Okay, and then for the oxygen, the valence electron for the oxygen is 6, but they only share 1 each because there is only a single bonding here. Okay, now the next one will be hydrogen. Okay, so if you look at here, they'll form a bonding at this part. 2, 3, 4 and 5. So when you calculate the dot and the cross, 2, 4, 6, 8 and 10. Okay, so I hope you can get the concept now. This is 10, your answer for number 7. Okay, now let us move on. Okay, for number 8, magnesium oxide has a high melting point and carbon dioxide has a low melting point. So magnesium oxide. So this is a 2 plus, this is a 2 negative. So they'll form an ionic bonding. Okay, this one is an ionic bonding. Now, if you look at a carbon dioxide, it's a covalent. Okay, which row identify the attractive force that are broken when these compounds are melted? Okay, now let us look at here. Okay, strong attraction between molecules. Okay, for magnesium oxide, it is not a molecule, it is ion. Okay, it is ion that reacts and attract together. So it should be either C or D. Now let us look at carbon dioxide. Okay, they have a weak attraction between atoms and weak attraction between molecules. Okay, for the covalent bonding, you have to understand this. Okay, let me draw it here. Okay, now we have this is one molecule of a carbon dioxide and another molecule of a carbon dioxide. Okay, so inside this molecule, they have a strong covalent bonding inside of these molecules. Okay, this is a CO2 and this is a CO2. In between the molecules, they have a very weak force, or we call it as a van der Waals force. So these are the forces that makes their bonding weak. Okay, so if you compare with this, okay, now they are asking for between atoms and between molecules. So let us go back to the picture here. Okay, so this is between atoms over here, between atoms, the inside here. And between molecules is between molecule 1 and molecule 2. Okay, so the weak force is between the molecules. So here it should be donkey as the answer. D. Between the molecules. Okay, now let us look at number 9. Okay. The ionic half equation for the formation of oxygen during electrolysis of aluminium oxide is shown here. Okay, now what are the values of X and also Y? Okay, since this is the number, so let me zoom here. Okay. Okay, please understand this. This number 2 is the number of molecules. Okay, it's the number of molecules. So we have to balance left and right for this equation. So when you have 2 atoms of oxygen, so here we have to put here 2. Okay, so each of these ion will be releasing 2 electrons. So when you have 2 atoms there, here will be 4. So it means the basic equation here will be this one. So if you put here 2 or 2, and here will become 4 electrons, and here will become 2 ions. Okay, so this one is 2 and here will be 4. Now let us look back at the question. Okay, this is number 9. Okay, now so the answer here will be donkey, D. Okay, now let us look at number 10. Okay, a compound that has a formula of XF2 and has a relative mass of 70. Okay, what is the element X? So here for fluorine is 19,9. So X will remain as X, and fluorine, there is a 2 fluorine there, so 2 multiplied with 19 equals to 70, and here's 38, so 70 minus with 38, and here will be the X. So the X is given as here will be 32. Okay, so the X is 32. So now we have to find which element has a relative mass as 32. Now let us look at the periodic table. Okay, this is the periodic table. So now let us zoom. Okay, now you can see, okay, this is the proton number and this is the relative mass number. So your answer here is this, sulfur. So they mentioned is a 32. Okay, so it's sulfur. Now we go back to the question. So the X here is 32, sulfur. Alright, so I hope you can understand this question. Okay, now let us go for number 11. Okay, number 11, the diagram shows a section of an overhead power cable. This is ceramic, steel, and also aluminium. Okay, which statement explains why a particular substance is used? So let us start with A. Okay, aluminium has a low density and is a good conductor of electricity. Yes, so we keep it aside first. Okay, now ceramic is a good conductor of electricity. Wrong. Steel can rust in a damp air. Unlikely. So steel is more denser than aluminium. Yes, it is. So, but why? The question asking why the particular substance is used. So we could say that A is the best answer. Because the reason here is this is overhead power cable. So when you're using aluminium, it is a low density, which means it's a less weight. So if let's say imagine we are using a steel for the overhead power cable, and the force will be higher. Okay, now let us look at number 12. Okay, number 12. During electrolysis, dilute sulfuric acid SO4. Okay, hydrogen is collected at the cathode. What is the ionic half equation for this reaction? So hydrogen is collected at cathode in the form of a hydrogen gas. So hydrogen in the acid appears as this. Okay, it accepts electron at the cathode and it forms a hydrogen atom. Okay, then the hydrogen atom is not stable, so they will combine to form a diatom. So which is a stable form of hydrogen. So they have a 2 here and they have a 2 here to balance it out. So these are the equation. So now let us look at number 12. So the best answer here will be C. Okay, now let us look at number 13. Okay, for number 13, which row describes an endothermic reaction? Endothermic reaction, it absorbs heat. Okay, it absorbs heat. So the graph should be this, the reactant, this activation energy, and the graph will end up with a higher energy level. So this is how it should be. So this one is more to exothermic, so it's not A. So now let us look at B. B is the most possible answer here. Okay, now let us look at C. This is exothermic, so it cannot be used. Now let us look at D. Okay, this is also a possible answer. Now we have to compare the B and D. Okay, now look at here. The energy is transferred from the reaction to the surrounding. So the explanation here is wrong. Okay, now let us look at the B. Okay, let me put a B and D together. Okay, for the B, the energy is transferred from the surrounding to the reaction. Yes, this is correct because they are absorbing the heat. Okay, so the B is the answer over here. And for your information, okay, let's say we do it in this way. Okay, the changes from the A to B, this is the heat absorbed, and the above here, this is the activation energy. Okay, so please don't forget that, students. Okay, so now for number 13, the answer is B. Okay, number 14, the equation for the complete combustion of methane is shown. Alright, the bond energy are shown in the table. Okay, what is the energy change for the reaction? Okay, so we have to understand here, this is heat is being absorbed at this side. Okay, this side, the reactant side, is heat is being absorbed, which means this one here will be endothermic. At here, let me use a different color. Okay, at this part, the heat is being released to form the bonding. Okay, heat is being released to form the bonding. So here will be more to exothermic. For the red color here, the heat is absorbed to break the bonding. Okay, now let us calculate. They have a methane. Methane is this. So they will have a here's H, here's H. So they have a C and H 410 multiplied with 4. They have 4 bondings. And let us look at oxygen. Oxygen is they'll form a double bond. So they'll form a double bond. So we have to multiply this with 2. So all together here will be here will be 2632. Okay, so we can ignore the unit first. Okay, now for the carbon dioxide is a C double bond with O. So they have a C double bond with O, which is 805 multiplied with 2. And let us look at water. Water is O and H. So they have a OH, and not forgetting the 2, number 2 in front here. So they have 4 bondings. So 460 multiplied with 4. So all together it comes about 3450. So since the exothermic is higher, so your answer here will be in negative form. So 3450 minus 2632. So your answer here will be in a negative 818 kilojoule per mole. So your answer here will be the A. Okay, that is for the number 40. Okay, now for 15. Okay, hydrogen fuel cell can be used to power cars. Statement about a fuel cell are correct. Okay, let me zoom here. Okay, now if you notice this, number 1, the balance equation for the reaction. Okay, if you balance it properly, it is not balanced actually. So we have to put here 2, and it will be 2 here. So it is not balanced. So number 1 is wrong. Even though the overall equation here is supposed to be this, but since it is not balanced properly, so it is wrong. So A and B is wrong. Okay, now the fuel cell generate electricity, yes, is correct. Okay, in a fuel cell, hydrogen is being reduced. So if you look at here, it is the oxidation number for this hydrogen is 0, and here will be a positive 1 for each. So which means it is being oxidized. Okay, this is being oxidized. So number 3 is wrong. And look at number 4. The reactants are gases at room temperature. Yes, hydrogen and oxygen, they are gas at room temperature. So your answer here will be 2 and 4, which is C. Okay, this is for number 15 here, guys. Okay.